Standard deviation is an average of deviations from the mean, and it measures the spread of the data. Now, the lower the value, the closer the data is together, and the higher the value, the more spread out it is. And I do have an example that shows this, but before we get to that, I want to talk about variance as well as the formulas for standard deviation and variance. So variance is the square of standard deviation. Now let's look at the formulas for standard deviation. This is the formula for the population standard deviation, and this is the formula for the sample standard deviation. We use an S for the sample standard deviation, and we use the Greek lowercase sigma for the population standard deviation. Uppercase N is the population size, lowercase n is the sample size, mu is the population mean, and x bar is the sample mean. And the main difference between the two formulas is that for population standard deviation, we are dividing by n, and for sample standard deviation, we are dividing by n minus 1. And n minus 1 is used for the samples so that the statistic S overestimates the parameter sigma on purpose. And lastly, to get from the standard deviation formulas to the variance formulas, we just need to square them. And that will remove the square roots, and you will get these formulas. So I want to show this example to really highlight what standard deviation is. So we have 6 data sets, and each data set has 7 items, and each data set has the same average. They all have an average of 13. So if you add up all the data items and divide by 7, you get 13. And that happens for each of these. But the data sets are all very different. So if you look at the graphs all look very different. And the first data set is starting out with every value being 13. So that is not spread out at all, which is why it has a standard deviation value of 0. But then as the data gets more and more spread out, you can see that the standard deviation value continues to increase. So the mean is the average of your data, but the standard deviation represents how spread out it is. Number 3 says, find the mean, variance, and standard deviation of the sample data set. So because the formulas for standard deviation and variance are kind of complicated, they take a lot of steps. But we are going to be building up to these formulas using this table right here. So first, I want to say how many numbers are in my data set. And n is equal to 5 because we have 5 numbers here. So I'm going to list those, and then I want to add them up, and that's equal to 30, and then divide by n to get 6. So this is my mean. This is my x bar. In the next column, I want to take x minus x bar. So each of those values in the first column, I'm going to subtract 6 from. And we get -4, -2, 0, 2, and 4. The next column is x minus x bar squared. So each of these numbers I want to square. And I get 16, 4, 0, 4, and 16. And then if we add all of these up, we get 40. Next, I want to take this value and divide it by n minus 1. So this is 40 over 5 minus 1, which will be 40 over 4, which is 10. So this is the variance. And then to get the standard deviation, we want to take the square root of the variance. So we are taking the square root of 10 to get 3.16. So for my final answer, the mean is 6, the variance is 10, and the standard deviation is 3.16.